Hello. A to the power of 2 minus b to the power of 2 is equals to 64. How do we solve for the value of a and b? Solution. We have a to the power of 2 minus b to the power of 2 equal to 64. Before we proceed further, we have a restriction. And our restriction is that a and b belongs to the set of positive integers. That is, a comma b is greater than or equal to 0. A square minus b square, we can rewrite it as a plus b times a minus b equal to 64. Now let us focus our attention on 64. 64 can be written as 8 times 8. Also, we can write 64 as 32 times 2. 64 can also be written as 16 times 4. Let's call this first line case 1, and the second line case 2, and the third line case 3. We will now consider each case. So, for case 1, we will replace 64 with 8 times 8. 64 equals to 8 times 8. From this line, we're going to have a plus b times a minus b equal to 8 times 8. This implies that this guy goes to this, and this guy goes to 8. So a plus b equal to 8, and a minus b is equal to 8. It is possible to add these two equations. So a plus a, that is 2a, b minus b is 0, equal to 8 plus 8, that is 16. Dividing both sides by 2, we have 2a over 2 equal to 16 over 2. Clearly, 2 cancels 2, so we have a equal to 2 here 1, 2 is 16, that is 8. So we have a equals to 8. Substituting this value of a into this second equation, this guy, we're going to have, since a minus b equal to 8, what is a? A is 8, so we have 8 minus b equal to 8. This implies that b equals to 8 minus 8, so b equals to 0. Therefore, a comma b is equal to, what is a? A is 8. We have 8 comma b is 0. This is the first solution. Now, let us consider the second case, case 2. When 64 equals to 32 times 2, so for case 2, 64 equals to 32 times 2. So a plus b times a minus b is equal to 32 times 2. This guy goes to 32, and this guy also goes to 2. So a plus b equal to 32, and a minus b equal to 2. We can add these two equations. A plus a, that is 2a. B minus b is 0, equal to 32 plus 2, that is 34. Let us divide both sides by 2. So we're going to have 2a over 2 equal to 34 over 2. 2 cancels 2. So a equal to 2 here 1, 2 here 17. So a equals to 17. Now, substituting this value of a into any of these, let's use this first one. Since a plus b equal to 32, what is a? A is 17, so 17 plus b equal to 32. This implies that b equals to 32 minus 17. So clearly b equals to 32 minus 17, that is 15. So therefore, a comma b is equal to, what is a? A is 17. 17 comma, what is b? B is 15. This is the second solution. Now let us consider the third case. Case 3. 64 equals to 16 times 4. For case 3 now, 64 equals to 16 times 4. So a plus b times a minus b equal to, we now replace 64 with 16 times 4. This guy go to this, and this guy go to 4. A plus b equals to 16 and a minus b equal to 4. Let us add these two equations. A plus a, that is 2a, b minus b is 0, equal to 16 plus 4, that is 20. Let's divide both sides by 2. 2a over 2 equal to 20 over 2. Clearly, 2 cancels 2, so the value of a is equals to 2 here 1, 2 in 20, that is 10. So a equals to 10. Substituting this value of a into any of this equation, let's use this one. Since a plus b equal to 16, what is a? A is 10, so 10 plus b equal to 16. This implies that b equals to 16 minus 10. So clearly, b equals to 6. Therefore, a comma b equal to, a is 10. What is b? B is 6. This is the third solution. It is good to verify if what we done is right. Let's check for each case. First, for the solution that we obtained for the first case, let us verify it. For case 1, a comma b is equals to 8 comma 0. The original question says a to the power of 2 minus b to the power of 2 equal to 6, 4. A is 8, b is 0. So let's substitute this guy into this left hand side. So we have 8 to the power of 2 minus 0 square equal to 8 square is 64 minus 0 square is 0. So this guy equals to 64, which is exactly what we have on this right hand side. So indeed, this guy is correct. So let's consider the second case now. To verify the second case now, a comma b is equal to 17 comma 15. The original question says a to the power of 2 minus b to the power of 2 equals to 64. Clearly, a is 17, b is 15. So let's substitute this guy into this left hand side. So we have 17 square minus 15 square equal to, so 17 to the power of 2 is 289 minus 15 to the power of 2 is 225. 289 minus 225 is 64, which is exactly what we have here. So that indicates that this second solution is also correct. Now, let's confirm the third case. Case 3 says a comma b is equal to 10 comma 6. So, the original question says a to the power of 2 minus b to the power of 2 equals to 64. Clearly, a is 10, b is 6. So, we turn this guy into this left hand side. We have 10 to the power of 2 minus 6 to the power of 2 equals to 10 square is 100 minus 6 square is 36. Doing the subtraction, we have 64, which is exactly what we have on this right hand side. So indeed, the third solution is also correct. So these are the required value of a and b. That's it. Thanks for watching.